Okay. Yeah, four layer. Thank you, ma. Four layer device. Okay. What are the three terminals? What are the three terminals? Control of high power. Sai Kumar. Yeah, good. Anode, cathode. Yeah, Dargas. Gate, anode, cathode. Yeah, Mogit, Shivata, Praizi, Gomati. Yeah. Okay. Thank you. Praizi and also gate, cathode, anode. Yeah, very good, very good. Okay, what are the three methods of? What are the three modes of operation of ACR? What are the three modes of operation of ACR? Yeah, forward. I think you have to type FBM. Yeah, Indrasena. Forward blocking mode, forward conducting mode. Komati correct. Darhas correct. Ajay Reddy forward blocking mode, forward conducting mode, and reverse blocking mode. Yeah, thank you, students. So I think you people were listening well. So that there are three modes of operation we have seen: forward blocking, forward conduction, and a reverse blocking mode. Yeah, yesterday we have seen till forward conducting mode. In forward conducting mode, what are the two methods of turn on the SCR? Forward conducting mode. Actually, we have seen with two conditions. Did you remember? Yeah, Mohit, correct. With gate and without gate. Yeah, with gate, with gate signal and without gate signal. Yeah, Rashmita is also correct. Yeah, thank you, students. So today actually we have seen mainly gate, anode. Oh, that's why you said amplification. Actually, mainly the thing is it is used in the rectification only. Okay, and gate, anode, cathode, and we all know it is a four layer device, PNPN. Okay, and three junctions are there, J1, J2, J3. Okay, and we have seen the construction by connecting P and N junctions J1, J2, J3. Three junctions were formed, and the current will flow in unidirectional anode to cathode only. So this is we have seen forward blocking mode, forward conduction mode, and reverse blocking mode. Thank you. Forward blocking mode. From forward blocking mode, we have seen where we will apply the positive voltage to anode and negative voltage to cathode, and J1 and J3 junctions are forward biased, and J2 junction is reversed biased, so there is no conduction of SCR. So SCR is in the off state. That's we have seen. SCR is in the off state. Okay, so that is forward blocking mode. So now forward conduction mode, we are going to turn on the SCR. Actually, we have seen with the two conditions, with the gate and without gate signal. So here what we did without applying gate, what we did, we just apply the voltage between anode to cathode. So at particular point what happened, a breakdown voltage will occur, and the current will suddenly rises, and the SCR put it in the on state. So but I told you this is not a safest method to turn on, so we always use the gate current. But in this condition we will apply the voltage. By keep on applying the voltage, a high voltage will be applied, and due to that, in J2 junction the avalanche breakdown will occur, and the device will starts to conduct, and it will put in the on state. Yeah, so I think next we apply the gate. So by applying gate, what is the use now? The gate current will be induced here, and due to the induce of gate current, the mobility of the ions, what happened, the J2 junction will occur a avalanche breakdown. Then automatically the four layer we have a current flow from anode to cathode terminal, and that condition is refers to as a gate condition. Okay, so we have seen with three gate currents, IG3, IG2, IG1. I told you we apply more gate current, it will be turn on with the less anode cathode voltage, and this is IG2 and this is IG1. So we have drawn for various gate current, and yesterday we have started, yeah, Rashmita told you the latching current and holding current. Very good, ma. So I told you it's one of the important two mark. Define latching current, define holding current is one of the important two mark. So I told you holding current. I told you minimum value of anode current required to maintain the SCR in conduction state. So once it reaches the holding current, now we can understand the SCR is in on state. So for example, I told you the 5 milliamps is a holding current of SCR. Now, once the SCR reaches that 5 milliamps current, the SCR is now turned on. But what is latching current? I told you while describing about SCR, we have to know SCR have a controlled turn on. That means I can turn on with control, but I don't have any control on turn off. So controlled turn on and uncontrolled turn off. So what happen now? What is latching current? Kindly note down. Once the SCR reaches the latching current, I can't able to turn off the SCR even though I detach my gate current. So how we can define latching current? Na? Minimum anode current that must flow through the SCR, in which the SCR will be turned on. If the SCR is move on to the forward conduction state, where even my gate current is detached, still the SCR will be in the on state. So once it reaches that latching current, I can't able to turn off my SCR. That is, I told, even though I remove my gate current, the turn, or even though I get, detach to my gate current, still my SCR goes to forward on condition. So holding current is to maintain minimum anode current to maintain the SCR in on state. Latching current is also says the SCR is in on state. Once it reaches this anode current, even my gate current is also detached. I can't able to turn off my SCR. Okay. And I told you it's one of the important difference, ma. Please note down latching and holding current. Okay, latching current and holding current. From this, mainly we can say that holding current is always less than the latching current, and latching current is always higher than the holding current. So you just see, this is they have seen like this current is always below the latching current, and this is always above the holding current. Okay, and this is allied with the turned off method. You just see this image, holding and latching. So what you have understand and all now. So once I will take that image and I will put it here, then it is easy for you to understand. Uh, so you just see, first one is definition. Already we have seen the definition. The same definition is given. Okay. The second one is, you see the second one, latching is aligned with the turned off and holding is aligned with the turn on method. Why they are saying now? Once it reaches the latching current, I can't able to turn off my SCR. Once it reaches the holding current, it denotes that my SCR is turned on. So that's why they have given this definition. Then this is the thing they have to denote that this is always um, this latching current will be always higher than the holding current, and holding current that denotes the value, the latching and holding current, how they are defining. And then this is they have given in spreadsheet, they will mention what will be the value. Okay, so I think you have understand this. The next one is reverse blocking mode. The third mode of operation, reverse blocking mode. So what is a reverse blocking mode? So I told you already in the SCR operation, while we are see without gate, my SCR will looks like a diode. That's why I told you it's mainly used in the rectifier operation. So when you see that, a reverse bias condition means how we will apply the voltage, ma? We will apply the positive voltage to how we will apply, you just see, anode and cathode, we will apply the negative voltage to anode and positive voltage to cathode. This is reverse bias. Are you clear? In forward bias, to in both the condition, we apply positive voltage to anode and negative voltage to cathode. Reverse bias or reverse blocking mode, it is similar to the reverse bias condition of the SCR as a diode. So what we are doing, we are applying the negative voltage to here and positive voltage here. So by applying the negative voltage, what happened? My J1 junction and J3 junction are reversed biased, but my J2 junction is forward biased. Are you clear? So in reverse bias and blocking mode, you just see cathode is made positive with respect to anode. So cathode is positive and anode is negative, and J1 and J3 are reverse biased, and J2 is move on to the forward bias. So this drives SCR into the reverse blocking mode. So reverse blocking mode means a small leakage current will be flow. So I told you only while I'm operating my switches, it have two condition: turn on, turn off. So in forward conduction blocking also SCR will be turned off. In forward conducting mode, SCR become turned on, and in reverse blocking also the SCR will be turned off. So turned off means what? It is a considered as a open switch. So open switch, high leakage, small current flows now. Obviously, impedance means what we used to say. It's the resistance values will be very low. So if the reverse voltage is, we keep on apply the reverse voltage, then obviously what happened? J1 and J through the avalanche breakdown will occur, and then the reverse current will flow in the SCR. So if even we apply more reverse voltage, that will considerable damage to the SCR. So you just see this here. I'm going to explain. I think you have understand this modes of operation, and this mode you just kindly listen. So what we are doing, we are applying the negative voltage to anode and positive voltage to cathode. So by applying that, what happened? J1 junction and J3 junction are reverse biased, and J2 junction is forward biased. So from that, what you have understand, a small leakage current is flowing on this junction. So a small leakage current, what I'm doing, I'm keep on applying the voltage. You just understand this is VI characteristics. So in this VI characteristics, you see a small leakage current is flowing. So I'm keep on applying the small once it apply the, once it reach its breakdown voltage, what happened? The current will flow, but what they are saying, even though it's a reverse blocking stage, a small leakage current only flow in the order of microamps, but still you apply the high reverse breakdown voltage, it will damage the ACR. That's why they give this a region. This is the maximum sustainable voltage in the reverse breakdown voltage, and this is the forward breakdown voltage where I can apply it. I should not apply beyond that voltage, that will damage the SCR. So each SCR have a rating. So beyond that, we should not operate that devices. Are you clear, ma? Have you understand this? Students, have you understand the reverse blocking mode? Are you there? What happened? Yes, ma'am. Okay, okay. I thought there is any problem in my net. Okay, thank you, students. Okay. Okay, so and one more thing, this can be asked in 2 mark, ma. Okay, we are not going to study in detail whether SCR can be represented as two transistor family. I think what's the problem on? I can't able to view your chats. Okay, okay, yes, ma'am. What is SCR? Ha ha. ha. Sujan Kumar. What is SCR you are asking? Yesterday you are present or not, Shujan? I think you are belong to artificial intelligence. Shujan, reply me. What is SCR you are asking? I thought yesterday half an hour and today present. Then why you are asking what is SCR? SCR, I told you, silicon controlled rectifier. It is a electronic device which comes under the thyristor family, where it having the three terminals: anode, cathode, and gate. It have a four layers with PN, 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 and having the three junctions: J1, J2, J3, where we have seen with three modes of operation. Okay, ma'am, I was confused. What confused? Okay. I think you can. I had got one more question from Dargas. What is the maximum reverse voltage we can apply? Dargas, I already told. There is a electronic sheets for each and every capacity of SCR. Now I have shown one SCR image which having a less 30 volt, or they will keep maximum 30 volt, 515 milliamps current. But handling with high capacity, high power devices, it having more voltage, right? Just they will keep some 200 volt to 5 ampere current. So it will depend upon device to device. Ma'am, we can off SCR within latching and holding current, as after SCR will not off? No, ma'am. Yeah, very good, Mogit question. Yeah, once that's why I told you uncontrolled uh, turn off methods are there. So what we do, we have some so many commutation techniques we use to say in power electronics that we are not going in depth for you. So that's why I stopped that, because your question, your first year, your simple question is explain the construction, working, and VI characteristics of SCR. That's it. So you have to explain, you have to draw the symbol, you have to draw the structure of SCR, and then you have to explain the construction, and then you have to explain the three modes of operation, and then you have to draw the characteristics. That's it. Okay. So here, what is the two technical term? Na, latching and holding current. So we are not going to see in the, actually the power electronics is one of the major part of electrical subject, where nowadays we have a tremendous improvement in the electrical, where drives in and I told you now SC for renewable energy and all, the power electronic devices only they are using. So the main component will be the thyristor family only we used. So there are so many turn off methods are there. So that is not needed in your according to your syllabus, so I didn't teach in detail. Okay. Okay, ma'am. So students, so this is the basic structure I have explained you, and I told you it can be asked whether SCR is a two transistor model. You have to say yes, because one, I can connect one PNP transistor and NPN transistor. You just connect NNN junction and PNP junction. So what you get, PNPN. So that's why they say it is told it's a two transistor model. So if they ask a two transistor model, you may draw this diagram or else this diagram. You all know PNP, you all know this will be your PNP structure, and this is your NPN structure. So here I will connect my anode terminal, and here I will connect in P, I will connect my cathode terminal. By tying both P junctions, I am connecting my gate current. Are you clear? So I think you are confused with this. You can draw this. SCR is a two transistor model. That's it. If they ask in 2 mark, they may ask in 2 mark, na, you are supposed to draw. Actually, you don't. You are not going to see in detail. They put this is anode current and this is my gate current. You all know entering current. The same way they defined a cathode current is equal to anode current plus gate current. Are you clear, ma'am? Okay. And the next one, applications. So applications of SCR, I told you in the power electronics, the major part is switching and rectification applications. The SCR is mainly used. Okay, so I think whole temperature control, heating, alarm activation, and industrial, mainly power converters, inverters, and all SCR have a tremendous applications, where it is controlled, used to control the motor speed and battery charging. I told you all renewable energy are equipped with thyristor family devices and all. So if you ask, if you want to remember one or two applications, you just write switching, rectification applications, and battery charging and power conversions. SCR will be your main applications. Why I put all the applications, and while I'm sending the PPT, I will restrict and I will highlight only the important application. Okay, so from the name itself, you can remember it will be mainly used in the rectifier. Is clear, ma'am? Okay. Okay. I think I have asked there itself. What are the three modes? You have already replied me. Forward conduction mode, forward blocking mode, and reverse blocking mode. List two applications of JFET and SCR. I think now only we have seen for SCR. Can you able to tell the applications of JFET? JFET, anyone? Applications of JFET, ma? Yeah, forgot. Huh? You all forgot. Applications of JFET. Yesterday I have discussed nearly some 18 2 marks in JFET. Why ma? No questions. JFET is mainly used in power amplifiers and logical switches. Are you clear? And you have to define holding current, latching current. Draw the symbol of SCR. I think, did you remember the symbol? Okay, I will draw it here itself. While you're drawing the symbol, anode, cathode, gate. That's it. Now you see, explain the construction, operation, VA characteristics of SCR. Actually, this will be your part B question. Is clear? Okay, students. Okay, next we will see another device, uni-junction transistor. How many devices so far we covered, ma? Can you list out the device's name? Why there is no chat options for me? Any problem on chatting? Yeah. Yes, ma'am. We remember. Okay, okay, okay. What are the devices we have discussed so far? JFET, SCR. Okay. Hmm. Only JFET, SCR. Ma'am also explained the devices. BJT. Yeah, okay. MOSFET I didn't explain, Indrasena. Indrasena, I didn't explain MOSFET. MOSFET I have allocated tomorrow to teach. BJT, diode, yeah, diode ma'am have explained. PN junction diode and Zener diode. Okay, so PN junction diode, Zener diode, BJT, JFET, SCR. Five devices we have seen. Yeah, Gautami consolidated that. Okay, five devices we have seen. Yeah, thank you, students. So only two devices left out. One is UJT and another was in MOSFET. So today I will try to complete UJT, and tomorrow we will see MOSFET. Please, students, listen, because the device working will differ from one device to another device. So I think yeah, so many Ajay Reddy, um, Hemant, Sai Prasad, Srivatsa, Rashmita, Praveen Kumar, Anshu, Arun Mogit, so many have put. Thank you, students. So I think now we will move on to UJT. I think I have put the image of UJT. You just see, this is the image of UJT. And if you have one black, uh, this is I told you yesterday. What is this, ma? What is this black? Hmm? I told you what is the name of this. Oh no, answer. This is device. Why they have connected this? Forgot, ah. Heat sink. I told you na yesterday, if I want to protect the device from the temperature and surroundings and all, it is always protected by one heat sink. You just see, this is heat sink, with heat sink and without heat sink. I have put two images, with heat sink and without heat sink. Okay, now we will enter into UJT. I think while we are discussing about the semiconductor family, we have a three families are there: diode family, transistor family, thyristor family. So UJT is also comes under which family? From the name itself, you can say which family, ma? It is okay. I am getting the message. Yeah, yeah, yeah. Transistor family. Okay, okay. Transistor family. Okay. Thank you, students. So I think uh, in UJT, what are the three terminals? Base one, base to emitter. You just see, this is my symbol of UJT, where it having a three terminals, base one, base two, emitter. And you all know this UJT, very simply, it having only PN junction, only two layer is there. So it will comes under which device, ma? Two layer device. It comes under which family? Transistor family. Okay, and you all know it will comes under which bipolar or unipolar. From the name itself, you can say it's a unipolar device. So from the name itself and from the structure itself, you can conclude it is a how many layer device, how many terminal device, it comes under which family, and what is the, yeah, I'm, Yeah. Rashmita, correct. Okay. Dargas, Lakshmi Kavya, yeah, put. Thank you, students. So you have to understand it's a only PN junction. Okay. And you all know this N-type silicon is heavily doped with P-type material on one side. There I am connecting my emitter terminal, and through two terminals, base 1 and base 2 is connected. And this is my symbol. Are you clear? And this is my basic construction. I think I told you yesterday itself, you have seven devices now. You have to remember seven working, seven construction, seven VI characteristics, seven symbol. All this thing you have to remember. So you have to remember it is a emitter, base 1 and base 2. Okay. Now they have explained the construction of UJT. So UJT having a three terminal, only single PN junction is there. So UJT has a emitter and two bases. It's not like a normal transistor. It having some negative resistance characteristics. I will explain you while I am explaining the working. Okay. And it is a PN junction, means you can remember it is similar to like a form of diode, but in diode we have only two terminals, where we have two base terminals, base 1 and base 2. Why it is called as an uni junction? It have only one PN junction. That's why it is called as an uni junction transistor. So we have seen in N type silicon bar, I have connected my P type material, where there I have connected my emitter. Okay. So I think students, you have understand what are the three terminals and here. Okay. So you all know this is my UJT internal block diagram, and this is my UJT symbol. But you all know UJT have a internal circuit model is very very important. Are you clear? Because while I'm explaining the working of UJT, this internal circuit model is mandatory. So what I am doing, I'm in the N type silicon bar. I have connected my base 2 and base 1. So I can represent this base 2 and base 1 by here by one resistance. Okay. And here by one resistance. That is this RB2 and RB1 resistance. Are you clear or not? So I am connecting my RB1 and RB2, base 1 and base 2. So simply representing by resistance. And it is forms a PN junction. So I am representing here the diode. So the UJT simplified internal circuit model is very very important, because while I'm explaining your working of UJT, I have to explain this. Are you clear or not? So RB1 and RB2 I'm representing the space by the resistance, and PN junction I'm representing by the diode. Are you clear? So I think you can know this. This will be your internal block diagram, and this will be your circuit model, and this is your symbol. Are you clear or not? Okay. Now I'm going to explain the working of UJT. So students, kindly listen well, then only you will understand this. It's very simple thing you can understand, because only PN junction is there. So one important thing is here, no, only two condition, turn on and turn off methods are there. So in SCR you have studied three modes of operations, and you have explained there. But here you are going to see only UJT on, UJT off. Okay. So the working of UJT, I told you, understand by its equivalent circuit. So without without having the equivalent circuit, you can't able to. Okay, I'll take care. Okay, so you can have. We are going to explain by its equivalent circuit and the voltage applied at the emitter. Are you clear? I think I'll take my pen. Okay. Oh, I gone. Okay. The voltage applied at the emitter is indicated by VE. So listen. So this is my emitter voltage. VE. VE is my emitter voltage. And the internal resistance are indicated by RB1 and RB2 at the base 1 and base 2. So I told you that are the resistance RB1 and RB2. Both the resistance are present internally together, are called as a intrinsic resistance. Okay, that is nothing but RBB. Okay, intrinsic resistance. Then the voltage across RB1 is V1. Okay, the DC voltage applied, the voltage across RB1 is V1, or here in the diagram they have represented as a VRB1. Both are same only. Okay, and then we have applied the voltage VBB with emitter open. That means I'm not applying the emitter voltage. Now I will explain you. So please listen, students. I think you have understand this. I will explain you. You take this VBB voltage as a 10 volt. Okay, I'm going to explain the working of UJT. So you consider this RB2 is 3 ohm resistance, because it is very nearer to my emitter terminal. So comparatively, RB2 will be less than RB1 only. Okay, consider RB1 as 7 ohm resistance, and you ignore this point 0.7 voltage. Emitter is open. So what will be the voltage across VRB2 and VRB1? Kindly tell me. Just you see, I'm going to see this. Okay, I'm going to apply my 10 volt here. Okay, and I'm telling this was 3 ohm resistance, and this is 7 ohm resistance. Okay, and here my emitter is open. I'm not applying any emitter voltage, so that is 0 volt only. Okay. uh, yeah, students, tell me what is the value of, have you calculated? Yeah, VRB1 is 10 volt. VRB1 is 10 volt. What, Indrasena? Yeah, good. VRB2 is 3 volt and this is 7 volt. Yes. Why you people are not Mohit Goodma? This is 3 volt. Totally 10 volt is there. So voltage drop across here will be 3 volt, and voltage drop here will be 7 volt. Why ma? Why you fall forgot I equal to V by R? Am I correct or not? V divided by 10 divided by 3 plus 7. So what is my current value? 1 ampere. So 3 into 1, 3 volt. 7 into 1, 7 volt. Yeah, yeah. What nega 1? Why? Rashmita correct. Bhavana correct. Indrasena, what is 1 ampere you are putting? Okay, unit is very important. Yeah, 1 ampere. Okay, okay, okay. Okay, ma, I can understand. Okay. Now you see, and my emitter voltage, So that's they have put it here. You just see VRB1 is equal to VBB into RB1 into RB1 plus RB2. Can anyone tell what is this formula which relate the formula in your first unit? Did you remember anyone? Anyone remember this? VRB1 equal to VBB into RB1 by RB1 plus RB2. Actually, we find out, but I'm saying we have find out the current and from the current. But can anyone remember that? Yeah, yeah. Voltage la, Mogit, Anushu, Ajay Reddy, voltage division rule, Gautami. Yeah, yeah. Shivam Pandey, how come parallel combination? Mm? It's a series circuit. Here circuit is open. Okay, yeah. Voltage divider rule. I think I hope you have remember this formula. Total voltage. Are you clear? VBB, total voltage into particular resistance by sum of the resistance in the loop. So this is the way to find out VRB. Okay. Now if I am connecting my VE, you just take this loop alone. Are you clear? Okay, 7 chats are there. Okay, actually we find out the VRB1 by use finding the current, and from the current we find out the voltage, or else this formula I can use directly without finding current. Total voltage into particular resistance by sum of the resistance. So apply the same formula here. VRB1 equal to 10 into RB1. What is my RB1? 7, and 3 plus 7, 10. So 10, 10 get cancelled. So what is my VRB1 value? 7 volt. Okay, I'm getting. Okay. Now I'm connecting my VD. You just take this loop alone. So this loop alone, what is my VE value? You just see VE equal to what, ma? VD plus VRB1. Okay. VD plus VRB1. Okay, they have said that this eta is nothing but intrinsic standoff ratio. Eta equal to RB1 by RB1 plus RB2. It's one of the important terminology in UJT, and they may ask what is intrinsic standoff ratio there, which is defined by using the resistance of base 1 and base terminal, and it is defined by the ratio of base 1 resistance to total resistance. Okay, so eta equal to what more? RB1 by RB1 plus RB2. Are you clear? So V equal to VD plus VRB1. So instead of we all know what is the formula for VRB1? VBB into eta. Am I correct or not? VBB into eta. Eta is my standard. So EV equal to what I can write? VD plus VRB1. How I can write? VBB into eta. Okay. Now, yeah. Now, can anyone tell at what condition the diode will turn on and what condition the diode will turn off? Can anyone tell? It's mainly depends on V value only. Praveen Kumar, VD 0.7 voltage is nothing but cut in voltage. You just leave it at what condition my UJT will be turned on and what condition my UJT will be turned off. Okay, I will tell you. Whenever my anode voltage should be greater than the cathode voltage only. Am I correct or not? This point, this is my anode point. Am I correct? And this is my cathode point. So whenever my anode voltage is greater than my cathode voltage, obviously at that time only my device will start conducting. So my V should be greater than VD plus VRB1 or VBB into eta. My UJT will on. Are you clear? Whenever my V is less than that VD plus VRB1, my UJT will become off. Only this is the modes of operation of UJT. Only this two. Can you understand or not? So we have seen what is VRB1, and we are kept first the emitter open. Emitter open, we are not applying any voltage. So UJT is, so what we have to do? We have to increase my emitter voltage. Then only the UJT will be turned on. Is clear? Have you understand this point, ma? Have you understand? Whenever my emitter voltage, yes, Indrasena, you have understand. Yeah, Venkatan also. So whenever my emitter anode voltage should be greater than VD plus VRB1, my UJT will be turned on. Whenever my V is less than that voltage, then my UJT, my cathode voltage will become higher. So my UJT will be off. So working of UJT is that. So now I will go to your slide and I will explain you. Now you will understand very well. Are you clear? Have you understand that? So at starting, the UJT will be turned off when emitter is open. So you have to keep on applying the emitter voltage. So at that particular voltage, when the anode voltage is greater than the cathode voltage, then automatically UJT will be turned on. Yeah, okay, Nega. Okay. So here they are saying the same thing only. So first, a small leakage current base to emitter due to minority carriers will be flow, and here they have put V1 and all na. V1 is nothing but VRB1. Okay, so VRB1 only we are saying. So still that value will be less. My UJT will be turned down. Once my input voltage, that is my emitter voltage, exceeds that VRB1, then automatically the PN junction will be forward biased, and then automatically the device will conduct, and then there I always told you it's a negative resistance. Why? Because now due to the application of voltage, the resistance get decreases. That's why we will say it's a negative resistance characteristics, and the device will be in the on state. So still my emitter voltage is zero, or it is less than the voltage across the RB1, my PN junction will be reverse biased, and the device will carry the small leakage current. Whenever my emitter voltage exceeds that base 1 voltage, then automatically coals will be injected in the p-type material and into the n-type bar. Then automatically what happen, the two layer will carries the current, then the current will flow, and automatically the resistance by application of the voltage, the resistance get decreases and current gets flow. So that's why we told it's a negative resistance characteristics device. Okay. So the next one is how we have seen latching current, holding current, and all we have seen. Similarly, intrinsic standoff ratio. So it is the ratio of RB1 to sum of RB1 plus RB2. So normally that is eta. Eta equal to, this is the definition, RB1 by RB1 plus RB2. It's one of the important two mark, and the value will be around 0.54 to zero point 0.8 intrinsic standoff ratio. Because the intrinsic standoff ratio only, because we have written the formula V equal to VD plus uh, eta into VPP. So this is also plays one of the important role on turn on UJT device. So that's why the intrinsic standoff ratio will be always taken into the account for the UJT for analyzing the device. Okay. Now students, have you all understand the working? So first we have seen the UJT terminals. What are the three terminals, ma? What are the three terminals? What are the two terminals? What are the three terminals, ma? Yeah, B1, B2 emitter, Sivasai Teja, super. Okay. And it is a two-layer device, I told you. It comes under the transistor family. The construction we seen, working, we have seen working very simple. Whenever the emitter voltage exceeds the voltage of VRB1, the device will conduct. Otherwise, the UJT will be turned off. Okay, dear. So now we will see about the VI characteristics. So far, VI characteristics, I will be drawn here and we will be drawn here, but here you just see it is in the thing it is denote reversed here. So VE and IE here. So you people, we are going to see some terminology related from this characteristics. So first of all, you have to see there are three region in this characteristics: cutoff region, negative resistance region, and saturation region. Okay, you just correlate with the working and you just relate the characteristics, then you will understand very well. Okay, so at the point initially V is 0. So initially what happened, my value of V is 0. So a small reverse current will flow. Okay, that is this portion. So a small reverse current will flow. So V reach at a point, my device is going to conduct. So what I am going to do, small reverse current will flow initially. So now what I am doing, I am going to increase my VE value. So you just see this is my y-axis is denotes my VE. So I'm increasing my VE value. So okay, so I'm keep on increasing. So while I'm increasing at one particular point, what happened? Once it attains that peak voltage in means what? At some voltage that VE should be greater than this eta VBB plus VD. At that point, my UJT starts conduct. That particular voltage is called as a peak voltage. Don't confuse with pinch off. Pinch off also we put P. Okay, that is the pinch of voltage. Where we studied the pinch of voltage, ma? Where we studied the pinch of voltage? Where we studied the pinch of voltage? Yeah, JFET, Mohit, yeah, correct. Bhavana, correct. Crazy, correct. Okay, thank you, students. Rashmita, correct. So here BP stands for peak voltage. At that peak voltage, what happened? The current is also peak. Okay, the current, you all understand that this in this particular region, my current is also my peak voltage. The voltage is also high, and my current is also say. So at that term, my UJT will be turned on. So this is my region where even though my current is still high only, my voltage will be falls below. So this is called as a negative resistance region. Negative resistance region essence means what we are saying that now, the portion in the graph till now termed as a cutoff region of the uh, UJT. So what we do, still we further increasing. I reached my peak voltage. Still I'm increasing my VE. So still I'm increasing my VE. We all know the formula for VE. What is the formula for VE, ma? VD plus eta VBB. Eta VBB means, okay, I will, VE equal to VD plus eta VBB. Eta V means intrinsic standoff ratio. So RB1 by RB1 plus RB2 into VBB. Okay, so what happened? Still become my RB1 is also get increased. So and then the voltage V1 also decreases because due to the increase in current V1. So that's why it is called as a negative resistance property, negative resistance region. Normally we all know V equal to IR. Whenever my resistance increases, my voltage should increases. We all know. So but here still due to that my V is further increased, the resistance RB1 and then V1 also decreases, but the current through it get increases. This is called negative resistance property. So this particular region is called as a negative resistance region. Have you understand? So once that VE reaches the VV point, valley point. Okay, once the V reaches the valley point means what happened? It's still then my current is also get increases, and then what happened? My voltage is also get increases. So this is my cutoff region, and this is my negative region, and this is my saturation region. So here my UJT will be turned off, and here my UJT will be turned on in this region. But here once it reaches my peak point, what happened? Still further VE get increases. Again what happened? My RB1 and voltage is also it decreases. So due to the negative resistance property, so what happened? The further increasing in current, voltage get falls. So that's why this is this region. And then once again what I'm going to do, till reaches my valley point, still I'm going to increase my current. And due to increasing in my current, and this is a saturation current, my current value get increases. So you have to understand that cutoff region, negative resistance region, and then saturation region. Are you clear? So that's why they have characteristics of the UJT. So they have explained three regions. So cutoff region, my UJT will be still off. So once I have reached my negative region, my UJT will be turned on. And in that turned on region, still I apply my voltage, emitter voltage. What happened? My emitter voltage will drops to valley voltages. And but even my current is also increases. You just see, this is my x-axis, but my current will be keep on increasing only. So actually we will operate in this region only, we will operate in this region only, UJT. Saturation region where the current and the voltage rises if the applied voltage the emitter increases. Okay, so this is my UJT region where the negative resistance region, and this is my saturation region. So here my UJT will be off, and in this region my UJT will become on, and still increasing of that albeit what happened, my voltage will falls but my current will on only. I told you, whenever current is high, the device is on only. So here also on, here also on, but this is the safe period where I can operate my UGT. Are you clear? Okay, application. UJT mainly used in relaxation oscillators, phase control circuits, and firing the thyristor. Firing the thyristor. Actually, why the firing the thyristor? Na? Here I am applying, getting anode, cathode, gate is there. Na? The gate, for the gate I will apply only the gate pulses. Now the gate pulses will be applied by UJT. So UJT is mainly used in providing the pulses. Actually, when you see about UJT, it is mainly used to give a pulses for the digital circuit. So while you are applying the writing the application, you have to remember the point. And one more thing, firing in sense means whenever I apply my gate, my thyristor starts conducting. So while you're getting your UJT, your pulse, you will get like this. Okay. So UJT will be used in the oscillator circuit. I think, ma'am, only theory part is there in this unit. Yes, Anshu Yadav, only theory part is there. Okay. Write the applications of UJT. I think while you are writing the applications, I told you it will be mainly used in the relaxation oscillators, are used to provide the pulses for digital circuits, thyristors and all. Define interstitial standoff ratio. What is interstitial standoff ratio? Now only I told you eta. What is eta, ma? What is eta? RB1 by RB1 plus RB2. Okay, and you draw the circuit and equivalent circuit symbol. I think you all drawn the symbol where my base 2, base 1, and emitter will be there. Okay, emitter will be there. Okay, n means the arrow mark will be inwards. Is clear? Explain the next. What is the question? All this question will be common. Explain the construction, operation, VA characteristics. So I think I can give you one simple thing after completing that. I will take. So tomorrow, students, today one work I will assign to you. Okay, take your notebook. You are supposed to. I don't know what happened. Okay. Okay. Tomorrow. Oh my God. Why? What happened? Okay. Tomorrow, students, you are supposed to take your notebook and do this work. Okay. Put serial number. Okay. Here, device. Okay. Tomorrow, I will expect everyone have to write in your notebook. I will unmute yourself, or else I will ask you to turn on your video to show to me. Okay. One more device you have to write, that I will give you. After completing that, you write, include that also. Serial number, symbol. Okay. Symbol, and then VA characteristics. All the device having VA characteristics. Then construction. Construction. This 5 tabular column you are supposed to put, and you have to write. What are the device now? PN junction, Zener, BJT, JFET. I am writing in which order we have taken. SCR, UJT, and the last one is MOSFET. Actually, I will give you MOSFET also. Tomorrow I will teach you how can you have understand this, because so far we have understand how it is working and all. So you just write this for 7 device, and tomorrow I will expect everyone have to show to me. Is clear? You please kindly take down this snapshot, or else you note down serial number, device. Is clear device? You try for PN junction, or you clear, sorry, MOSFET. I will teach you tomorrow. MOSFET also we have the types. So tomorrow we will see this. Everyone have to write it in your paper. We are supposed to turn on your video and you are just show your page. PN junction, diode, Zener diode, BJT, JFET, SCR, UJT, MOSFET. Draw the symbol. Okay, in the symbol, below the symbol you have to abbreviate the terminals. If you put A, write A anode. Are you clear or not? If you are here, you are drawing the symbol of here, diode na, A na, anode, cathode. And similarly you have to draw the VA characteristics. You have a two region, forward bias and reverse bias. Okay, that. And then you have to explain what is the construction. Okay, in the construction you have to explain it is having a P and A. Only diagram, no need of any theories and all. Only diagram. Are you clear? A, K you have to draw, but theory I'm not explaining you. So put one tabular column, and you, I am getting only two. Okay, ma'am. One from Arul Mogit, and another from Akula. Art about, yeah, Devi Renuka. Yeah. Devi Renuka, you didn't put your number and you log in, Devi Renuka. Why? Repeatedly we were giving the instruction, please log in with your Then how can we give the order? Every time I have to remember your number is 6102. Am I correct or not? Devi Renuka? Hmm? I have to remember because you won't log in with your number. Share this PDF, ma'am. Remember, tomorrow only we will share the PDF, Ganesh. After on Telegram we will share. Tomorrow we will share the PDF. Okay. And one more thing, after completing the MOSFET only, I will share. Okay. You have any doubt? You have any doubt on this portion, ma? No, no, ma'am. No, ma'am. Tomorrow after completing MOSFET. Okay. So people, have you all take down this snapshot, ma? Have you take down or not? Bhuvna ma'am. Thank you, thank you, thank you. Thank you, students. I have you have muted. Okay, okay, okay. I didn't. I forgot. Students, include the one, two, three, four, fifth column as your parameters. Okay, tell me the. Yeah, now I am unmute myself. Yeah, Jayshree, now I have unmuted. I forgot. Okay, so students, include the parameter as a last column. Now you tell me what are the parameter you learn in PN junction. What are the parameters you have learned? No. Okay, we will go in reverse. What are the parameter you learn in UJT? Only one param. What are the parameter and what is the formula for that? UJT you have learned about intrinsic standoff ratio. Okay, and then peak voltage, valley voltage can be asked. SCR, what are the terminology? Ma? There you have tried the definition. In parameter you write down the definition. If formula is there, mention the formula. Are you clear? SCR, latching current, holding current, you have to explain. When you move on to JFET, you have to, yeah, reverse voltage rating, yeah, good. In JFET you will move on to JFET. You have to write about transconductance, you have to write amplification factor, you have to explain. And in JFET, what are the other terms we have discussed? uh, is there any formula we have discussed in JFET? In transfer characteristics, did you remember? IDSS, drain saturation current is equal to 1 minus VGS by VP the whole square. Yeah, Pricey, correct. So in JFET you have to explain about the um, okay, I think it have some long. So I think we will. You have to show it on Monday, okay? Because I thought you have to consolidate and write. So if you share a PPT, it's easy for you. So okay, students, what you do? Prepare it on Monday, and one more on Monday. Thursday we will complete MOSFET, and we will share the PPT. Monday you are supposed to attend the Kahoot quiz, and similarly you have to show this format. Are you clear? So serial number, 7 devices, symbol, VA characteristics, construction, and parameters. So you write it on Monday. Tomorrow you need not to show me, you show it on Monday. Is clear? So all part B question is very simple. All the device, how the part B can explain the construction, working, and VA characteristics of the device. Whether it may be a PN device, PN diode, or Zener diode, or BJT, or JFET, SCR, and all. Okay. Can I show tomorrow, ma'am? Tomorrow, no. I am absent on Monday. Devi Renuka. You okay? Okay. If you are prepared, you can show it tomorrow to me. Is clear? Gate cutoff voltage, VGS. Actually, don't get confused. I will share it on Thursday, and you will take the PPT, download it, and you prepare it. Is clear, ma'am?
Hello, ma'am.
Yes, ma'am. Yes, ma'am. English, ma'am.
Yes, ma'am.
I think you came as a host, ma'am.
Yes, ma'am.
Okay, ma'am. Okay,
You can,
students.
ma'am, you can make me the host. I,
Uh,
I, I actually joined from Department of CSC login.
then you are the host only, ma'am.
Okay,
Oh,
because
I will make you host, ma'am.
yes, you have to make me.
Yeah, yeah. I will make you host, ma'am. Yeah.
Okay, ma'am.